Esteemed participants, distinguished guests, and faculty members present here, I am delighted to see you all here. I am Charanya Ramesh Dumre Patil, and it has been an honor hosting this series. It is with great privilege and pleasure that we extend a warm welcome on behalf of Amity University, Mumbai. Today's lecture will be delivered by esteemed speaker Dr. Mikashima Kohli ma'am. It is with great anticipation that we convene for another enlightening session for our Biology of Tuberculosis lecture series organized by Amity Institute of Biotechnology, Amity University, Mumbai. As we gather for final lecture of Tuberculosis lecture series, I am privileged to take a moment to reflect on the enlightening journey we have embarked upon so far. Across the course of this series, our exploration has spanned a diverse array of subjects. We have delved into tuberculosis eradication strategies, ventured into the realm of cutting-edge immunotherapies and treatment regimens, and touched upon the intricate interplay of host-pathogen interaction as well as crucial civil awareness and general health. Today, we culminate this intellectual voyage with an exploration into diagnostic landscape for tuberculosis research. So far, we have been honored to receive insights from various distinguished speakers throughout the series, including Professor Sarman Singh, Sir from ISER Bhopal, Dr. Deepak Kaushal, Sir from Texas Biomedical Center, Dr. Savita Kulkarni, ma'am from Baba Atomic Research Center, Dr. Anand Krishnan, Sir from University of Free State, South Africa, Dr. Ved Prakash Dwivedi, Sir from ICEGB, New Delhi, Dr. Amit Yadav, Sir, from THSIT, Haryana, and most recently, Dr. Pramesh Bhatnagar, Sir, from WHAI, New Delhi. Their experience has enriched our journey. In the realm of tuberculosis research, diagnostics serves as a cornerstone upon which effective interventions are built. This lecture serves as a beacon guiding us through the evolution of diagnostic techniques, technologies, and strategies that continue to shape our understanding and response to the global health challenge. As we embark on this final lecture, we delve into the realm where innovation and precision converge to uncover tuberculosis in its various forms. Our esteemed speaker and authority in this field will navigate us through the intricate tapestry of diagnostics, shedding light on how advancements are translating into swifter and more accurate diagnosis. This lecture encapsulates the essence of our lecture series, a journey through knowledge, discovery, and enlightenment. With gratitude for your active engagement throughout, let us now immerse ourselves into the intricate lecture of diagnostic landscape for tuberculosis research, uniting theory and practice in our pursuit for tuberculosis-free world. That said, I would like to call upon Dr. Sashank Kamre, sir, an assistant professor at AIB, to introduce the speaker.
So thank you, Sharanya. Good afternoon, ma'am. It is 3 p.m. As per the Indian Standard Time. So it is my great privilege to introduce Dr. Mikashmi Kohli. So she completed her PhD from All India Institute of Medical Sciences, New Delhi, and did her postdoctoral work at the McGill University, Canada, with the very big group, that is Dr. Madhukar Pai's group. She also worked with Cochrane Systematic Review Team on diagnostic accuracy of molecular test in tuberculosis, and she has contributed to WHO's policy work linked to TB diagnostics. She has been also a part of several guideline groups for TB diagnostics. She has also led several research projects which are linked to the accuracy of molecular TB diagnostics, as well as she has been able to assess the availability and accessibility of diagnostics in primary healthcare settings in low as well as middle income countries. So she is passionate about evidence-driven policies and implementation strategies for diagnostics in global health. So without any delay, I would like to welcome Dr. Mikashmi Kohli to give her talk. Thank you, ma'am.
Thank you, everyone, for the invite, and I'm really happy to be here and speaking on TB diagnostics. I will just quickly start by saying that TB diagnostics, and I hope that because this series has been on tuberculosis, and India is one of the countries with the highest burden of this disease, I find, and throughout my career up until now, I have been very engaged and very involved in how we can work on diagnostics for TB, and then patients being put on treatment. Because if you cannot diagnose what the problem is, you can actually not treat the patient. So I'm just going to quickly walk through the landscape of TB from the past, present, and what the future is looking like now. Next slide, please. Great, thank you. So just to put things into perspective, when we say that why TB, globally, there are about 1.6 million people who actually died from TB just in 2021. And the new report of 2023 will be out next month, but we are expecting the same estimate for the burden of this disease and people dying from this disease. Worldwide, after COVID-19, TB is the leading infectious killer, and it is even above HIV and AIDS. There is a growing problem of multi-drug resistance TB, and it remains a huge public health crisis and health security threat. And an estimated 74 million lives were actually saved through TB diagnosis and treatment between 2000 and 2021. Next slide, please.
There is some issue, just a moment. I'm again sharing. Yeah.
Great. Can you put that on slide presentation mode?
Is it visible?
Yes, thank you. So just to say that TB is not something that is happening now, or it's not something that just resurfaced from just recent years. It has been prevalent. It has been there with a huge burden itself since we know of the human civilization. Next slide, please. And it is something that has been there, that was also something that we discovered in the Egyptian mummies when they were excavated. And the mention of this disease has been throughout different periods from India to the Greeks to Europe and North America. And from 1600 to 1800, about 25% of the people, they were dying from this disease. And that is just to say that it is these deaths were not something that were happening only in India or in Pakistan or Southeast Asia or somewhere in Africa. This was something that was happening in Europe and the US also. There have been different names that have been given to this disease throughout the history, and there have been different concepts. How do you get this disease? How does it get transmitted, etc.? But one of the heroes for this disease was Robert Koch in 1882, who actually discovered what causes this disease. Next slide, please. And this is just a timeline and showing that starting from Europe, there was a sanatorium. So initially, now people actually who have the disease have the ability that they can walk, they can move around, get treatment, etc. But earlier, if you were actually diagnosed with this disease, you were put in a sanatorium, which was against all human rights, and it was really difficult to even get out of the sanatorium, and many people used to even die at that point. So saying that starting from 1857 up until 2002, there have been a lot of changes. There have been a lot of advancement up until 2002, 2006 was when we first discovered that there is a drug resistant form of TB as well. Next slide, please. Just to put things into perspective in terms of diagnostics, I think COVID in itself has showed us that what is the relevance of diagnostics. If there is something that you cannot diagnose, there is no point of treating the patient, because you might end up treating the patient wrong. People who were during the pandemic days, we know that there were cases where initially people started giving flu medicines. There were high broad spectrum antibiotics that were actually provided, and people didn't even know what to do if you had COVID. So you first need to get diagnostics, and there have been many papers, many op-eds and opinion papers that have been written on what the importance of diagnostics is. Next slide, please. And there was a publication, and I was one of the commissioners in the Lancet Commission on Diagnostics, and we actually came up to a very key conclusion that 47% of the global population has little to no access to diagnostics. So almost half of the globe does not have access to know if you have this disease or you don't have that disease. So we are actually running in blind. Next slide, please. So to talk about the diagnostic cascade, when I say diagnostic cascade, what I mean is that there is a person, if you go into a clinic, you have fever, you have been coughing for 2 weeks, you have low appetite, etc. You have some symptoms that could either be pneumonia, that could either be COVID, could be TB, we don't know. But you need to get a test. And then once you get a test is when you need to know what kind of treatment is if the test is positive, you are being put on treatment. If the test is negative, you do a test to assess what is it. And next slide, please. And when I say this cascade of care, these are the steps that we have been looking at in the realm of TB diagnostics, where we saw that through this cascade, once the patient goes in, if you have symptoms, how many people who actually go in with symptoms to actually get tested? So there is a huge gap, and the biggest gap in this care cascade for TB has been for diagnostics. So we see that in the 30 high TB burden countries, there are about 40% of the people who are not able to even get tested. And this was across low and middle income countries and even in high income countries. So at FIND, and also for something that I do have focused my career on, is to, one, get to understand if we can have new and better diagnostics for TB. And if we do have new and better diagnostics for TB, how do we get people who actually need these tests access to these tests? Next slide, please. So this is just a timeline of the diagnostic test. We are all aware of what microscopy looks like, and it was first done in 1882 when you could actually identify the bacteria. And then we all know about chest x-rays, a PPT test, which is now called as the THT or the Monto test, and then PCR or culturing, eGRAs, and lateral flow assays. So this was something that this is a very old pipeline, but this pipeline has evolved so much since this pipeline of 1999. Next slide, please. Now talking about the landscape and how this landscape looks like for diagnostics. Next slide, please. Okay, before the landscape, when we say that you have TB, there are different forms of TB. So the disease in itself has a huge spectrum, which starts from a person having an infection of TB to actually having the disease. So living in India, in some of the most populous areas, and I'm assuming that there are most of the audience from Mumbai. Mumbai is one of the is actually one of the hotspots for TB, and not only TB, but also drug resistance TB. So just to say that because we live in a high TB burden country, in an overpopulous area, maybe most of us are already infected, but doesn't necessarily mean that you have the active disease. So this picture is just showing you that there are different tests and there are different stages in the spectrum where you can get a test, be positive, but still not have the disease. So moving from infection of TB to having a latent TB infection to something called as subclinical TB, which we still cannot be sure that we have diagnosed subclinical TB, to actually having the disease. And just to say that it's this picture just shows about the infection in lungs, but there are other forms of TB as well. There are only two places, hair and nails, where you cannot get TB, but any other organ, any other part of the body, it is very possible to have TB, which is called the extrapulmonary TB. Next slide, please. So talking about the disease spectrum, so there are tests that can actually detect if you have the TB infection or not. And there are tests that you can get done in a screening mechanism to say you have symptoms, do you actually have something called as TB or not? And then there are some tests to confirm that whether you have TB or not. So next slide, please. So first, I think I'll be talking about the screening test, but just to say that even if you have a skin test, a Monto positive or an IGRA positive, it shows that you have an infection, but doesn't necessarily mean that the infection will lead you to have an active disease or not. Many people have infection and they never transfer to having an active disease. And many people who have infection, they actually get the disease within 1 year or 6 months or even 10 years sometimes. It is all the human immune system that works here. So focusing first on the triage and screening tools, how the landscape looks like for that. Next slide, please. So there is something called as, and you can press next for this entire slide, there are a little bit of animations. So one of the biggest screening tools for TB has been chest x-rays. All of us have gotten chest x-rays, and if any one of you have ever tried to get a visa for either the US or the UK, Australia, anywhere outside of India, you are usually asked to get a chest x-ray done. If you want to study abroad, you are usually asked to do that. One, because India is a high TB burden country. And second, it is a good screening tool to actually tell if you have some infiltrations in your lungs or not, to look for pulmonary TB. But what has happened over the last 5 years is that people, they go to a chest x-ray clinic, and then you have a person who looks into your chest x-ray. There is a doctor who looks at the film, and every person, this was a study that was done, that I could be reading a chest x-ray differently from how you might read it, or another doctor sitting in another clinic might read it. It all depends on the experience, your education, etc. But now the advancement in this technology, in this field, has been that now you have something called as AI-based chest x-ray detection, which is called computer-assisted detection for TB. And this is an AI-based tool that will look at your chest x-ray scan and can actually tell you whether you have a possibility of having TB or not. Next slide, please. And next, another one. And another one. So the advancement in this field is, and why it is helpful, is because there are many people, especially living in rural areas, where you cannot have a proper chest x-ray clinic. You don't have that facility, you don't have that infrastructure. And even if you have an infrastructure, you do not have a well-qualified person to read and be sure that they can read this chest x-ray properly. That is where you can actually have portable x-rays. As you can see, there's this person with the blue backpack, and he's actually taking the x-ray with him up into the rural areas or hilly areas. There are solar panels that can charge up these small portable machines. You can get a chest x-ray done, and then you can use the AI-based software to help detect whether you have a possibility of having TB or not. There is a landscape document that I've linked here. If you are interested, there are so many AI-based softwares that are now looking into this, and this from TB, these softwares then also were starting to use and get evaluated for COVID, because in COVID also your lungs were getting destroyed. So they started training this AI model to see if they can actually distinguish between COVID, pneumonia, TB or not. Next slide, please. And one more next. And another one. Thank you. Another fast-moving technology for screening is something called as AI-based point-of-care ultrasound. So again, if you want to get an ultrasound done, you need to go into a clinic where there is a proper ultrasound machine, there is a doctor who can look at that. But now the technology is moving faster, where if we want to actually test a patient or screen a patient, or especially infants and children who may have this disease, there are portable ultrasound. The image on the left, it's called the butterfly point of care ultrasound. It is a very small handheld device. You can take that into remote areas and can actually get an ultrasound done. And it is connected to an app, so you don't even need heavy softwares for that. Another AI-based technology is an AI-enabled stethoscope, where again, you need to check the cough sounds, you need to check how deep somebody is breathing. These are small, portable, digital stethoscopes that are connected to the app again. And then there are cough apps, which is very interesting because if you're coughing, some of these apps, and we are currently doing a study here from FIND, and we are doing the study in South Africa and Peru to understand that when you're coughing, can your cough actually detect whether you have TB, you have something as pneumonia, you could have COVID, or you're just coughing just because there is a lot of pollution, which can happen in a city like Delhi, for example. So this is another area where the landscape is moving very fast, and we are using AI-based technologies to actually screen for the disease. Next slide, please. And then there is the next, please. And one more. Thank you. So So another stage in the spectrum is the active TB disease. So you have screened that you may possibly have something on your chest X-ray. You now need to get a confirmatory diagnostic test done. There are so many tests that are actually available in the basket now to say to confirm whether you have TB or not. And we start with something called as microscopy, and then move to very fancy commercial WHO recommended PCR models. Next slide, please. Yeah, so to say that in the TB diagnostic test, so you need to test for TB, but you also need to test whether you have something called as drug resistance or not. There are many drugs. There are first line, second line, third line drugs for TB. But then when you say that, if you should be taking that drug or not, you also need to get a drug susceptibility testing done. So on the left side, the first bucket is the microscopy, culture, and phenotypic DST. These date back to 1800s when these tests were done, but they are still used. And culture, for example, is a gold standard test that we use for TB. For culture as well, there has been advancement done where initially it used to be a solid media culture, but now we have moved to more faster and a more efficient culture, that is a liquid culture, here done on midget. And then another thing that I do want to mention, especially in the Indian context, is something called as TB, the MTBC, the MTB complex, and something called as non-tuberculous mycobacteria, which is again becoming very prevalent in India. There are a lot of studies, even just by normal water sometimes that you drink, your mouth has a huge population of NTMs as well. But when you're detecting for TB, and in a country like India, where you have high burden of TB, where you have high burden of NTMs as well, when you're testing, you need to know what is positive. So that is where the speciation comes into play. And initially, we used to do speciation that used to take weeks, but now we have very rapid, easily doable, something as simple as a pregnancy test that is mentioned here, like an SD bio line that can help you detect whether it's NTM or MTBC. Next slide, please. And then you have something for antigen detection, which is one of the tests in this field is a urine lamb test. So it's liporabinomannan molecule that is actually given out or excreted in urine. And it is in high concentration, especially in people who have HIV. But also in HIV negative people, you can have that, just that we need to find better mechanisms to concentrate this molecule. WHO has recommended one of these tests called the Allaire-Lamb. Now it is called the Abbott-Lamb test. But there are a lot of tests that are coming up, and we are in the process of evaluating them. They are faster, they are more sensitive, and they promise to detect LAM even in HIV negative people, because right now, urine lamb has only been recommended for HIV positive people. Now, next slide, please. To say that, and the one area of huge interest for everybody has been the nucleic acid test. Even in the pandemic times, all of us were asking, did you get an RT-PCR done? Did you get an antigen test done? So nucleic acid amplification test is one area where everybody wanted to invest and wanted to do more for COVID. And the same thing was happening for TB as well. Next slide, please. And I will talk more about the nucleic acid amplification test now and where this field is going. Next slide, please. Yeah. So to say that there are many NAT tests that have been already recommended by TB. The first row here is the low complexity, easy to do test. I am pretty sure you all must have heard about Expert, MTB-RIF, Expert Ultra. And this is how it's like a modular test, and you can put in a cartridge and you get a result in 90 minutes. It has been recommended for TB and rifampicin resistance. Then the second test is the TruePrep or the TrueNAT. This is the first Indian manufactured test that has ever been recommended and evaluated by the WHO. And this was a huge win for the government of India and the Indian manufacturers that actually did this. Then there is the TB LAM test. That is the point of care test that you can do at the district level as well. And then there are high complexity assays called the line probe assays. These are reverse hybridization tests that can actually help you detect for TB, RIF, INH, and also second line drugs. And all of these have been recommended by the WHO. There are also more complex, more centralized tests, because most of these tests that I spoke about, Expert, TrueNAT, TB LAM, we are trying to use them in more like primary healthcare settings and smaller hospitals. Whereas for moderate complexity assays or centralized tests, the panel on the right here, where you see Abbott, you see Bruker-Hain or BD Max, etc. These are huge platforms, and at a given time, they can actually test for over 96 samples. So again, and Mumbai, for example, there are two big hospitals in Mumbai that I know and we work with. They have implemented these centralized platforms because they're high throughput, they have high sensitivity and specificity, and that is where we see this as having the maximum impact. Because if you're getting 200 samples in 2 days, you would want to get them done faster. Next slide, please. Great. So just to say that, again, COVID was one era, not that it's over yet, but when in the middle of the pandemic, everybody wanted to know, do I have COVID or not? And that actually was a game changing in terms of the technology advancement. We had artificial intelligence and machine learning that was happening everywhere. And as I just showed it to you, even just how you're coughing and your cough sounds can help you assess what kind of a cough you have. That is a huge game changer. Mobile devices, connectivity. Everybody was looking at online data. How many cases have been detected? What is the surveillance? There was public, the data was available in the public domain, and which was why it was easy to see where the high burden of COVID is, where should I be traveling, not, etc. Next generation technologies, CRISPR and sequencing. Just 3 weeks ago, WHO recommended targeted next generation sequencing for TB, and this has been done for the first time. But we were doing sequencing for surveillance for COVID, and India was one of those countries that actually had even mobile vans which were doing sequencing right outside the airport. Then you have wearables and home use tools. There are so many new tests where you can actually, like your Apple Watches. Similarly, we are trying to work in this space where you have some wearable that can actually tell that you've been coughing for 2 weeks now. Now it's time to go get a confirmatory test done. So something like easy to use, home-based testing, etc. So just to say that the landscape has evolved and changed so much that we necessarily do not need to go to the hospitals and clinics to get tested. There are many new innovations that are coming up in this space. Next slide, please. Yeah, and one more. So what I'm trying to say in this slide is that there are many innovations that are happening in the field of TB. Right now, if you need to get a TB test, you need to cough, you need to get a sputum out, or you need to do a CSF lumbar puncture, a lymph node biopsy, something like that. The innovations are moving in two directions. One is making more point of care, easy to do test. So I think everybody did a swab-based test for COVID. Similarly, we are trying to see, can we do a swab-based test for TB, which is easy to do? Can we actually use urine for testing for TB? So trying to make more point of care, easily doable test. And on the other direction, for countries like India, Brazil, Vietnam, Indonesia, China, where the burden is really high, can we actually generate and have more high throughput universal DST platforms where in a single test you can run many samples and you can not just test for TB, but you can test for many drugs at the same time. Next slide, please. And one more. And one more. Yeah. So this slide is just telling you that there are these new point of care portable machines. So the second one, the Lumira DX that I've mentioned here, it's a very small portable handheld device. And in 20 minutes, you can actually potentially get a result of whether you have TB or drug resistance or not. So there are smaller assays that you can place anywhere. Some of them are battery operated. You don't even need electricity for that. And then most of these companies actually invested a lot of money during COVID. Now they're trying to see that the burden of that pandemic is low now. Can we actually invest and try to build something similar for TB? Next slide, please. Yeah. And other mechanisms of testing, one potential is when you breathe, because everybody was wearing masks during COVID, but when you breathe into a mask, can you actually use a face mask to detect or screen for TB? And some of our exploratory studies have actually shown that yes, if you wear a mask and there is a CRISPR-based chip that is actually put inside that, can you detect TB using that or not? And yes, the studies have suggested that you can. Similarly, the one on the left is like blowing into a tube and there are aerosols that are collected in that tube. And when you put that into a detector, you can do a similar testing for TB as well. Next slide, please. And I just spoke about this, that how sequencing has now been recommended for TB. And this was the data that we generated at Find saying that there is a targeted next generation sequencing. The platforms that we used were Nanopore, Illumina, the BGI platforms, etc. And this is something that is actually useful because there are many drugs and people are becoming totally drug resistant as well, which is a huge problem in Mumbai right now, where none of the drugs work. So if you really need to understand to put a patient, what should I put my patient on, you need to be able to do an upfront DST for that patient. And next slide, please. Thankfully, the WHO has recommended TNGS to be used for diagnosing drug-resistant TB. And that's my last slide. Next slide, please. Thank you. And I'm happy to take any questions if you have.
So thank you so much, ma'am, for the nice and informative talk. So I have a couple of questions. So this nucleic acid amplification test, how do they, what is their diagnostic efficiency in case of the smear negative but culture positive TB cases?
Yep. So especially for something like expert that has been recommended, there is a lot of data that's already available. For smear negative, the sensitivity was somewhere around 66 to 75%, and the specificity was 98-99%.
Okay. So, and one more thing. So, all these tests that you mentioned, all are sophisticated and high-end tests. So, in specifically the country like India or Bangladesh, Pakistan, which are low-income countries, how do you think? How do the government go about the costing of this tests? I don't think they'll be available in so easily.
No. So India, for example, is a great example, and even Bangladesh, Nepal, Pakistan, even Afghanistan, for that matter. Export, when it came into the picture, we negotiated that for low middle income and high TB burden countries, the cost of the test should not be $10. But so that is a uniform agreement that everybody came up to, and the company provides it at that price. So company provides it at that price, but then I did a study where we tried to find out that in private sector, which is huge in India, the pricing was differing a lot. So one lab was charging 4,000, another was charging 6,000, 2,000, and then we made another contract, which was the IPAQT, is where we said that there will be a ceiling price. So above this price, no company, no lab can actually put that price. So that is one. And this is what we do when there are new tests which are very sophisticated that are coming up in the market. The first thing that we do is to have negotiated prices available for high TB burden, low and middle income countries. Similar was the case with TrueNat, and with TrueNat it was amazing because it was Indian built, and we had the same price cost of it started off with $9 and now it is at $7. So these tests are available, and the pricing is something that everybody takes into place, that they're available in countries where they actually need it.
Right, but actually, do WHO or Indian government has direct control over the private practitioners or private hospitals? Because in case of COVID pandemic, when the remdesivir injections were very much in shortage, that time the prices were ranging up to 50,000 also per injection in some of the private hospitals in India.
Agreed.
So do the Indian government or WHO have direct control over this kind of malpractice?
Sam, unfortunately, we don't. The WHO or even the MOH, even in India, the central government was not able to control that. The problem but however, that was in the middle of the pandemic, we didn't even know what we were doing. But from that pandemic, what the countries and some like the global policymakers like the WHO has learned is that we need to, before the test or before the drug comes into the market, we need to set those ceiling prices upfront. Right. So at least for testing or for drugs also, there is a ceiling price that before introducing it into the market, that is one mandatory thing that people are trying to achieve. That being said, I do myself know that it is really hard to control the private practitioners. But there are constant efforts that are happening. In fact, the government is now trying to contract the private practitioners to kind of come up with a contract with them so that people don't have to pay out of pocket prices. There is a contract with the government. It's called the PPP model, and the government is currently working on it.
Okay, one more question. In the lamb-based test, so how does it cope up with the structural variability of the lamb?
Yeah, that's a good question. The structural variability, again, depending on, especially with HIV negative, we knew when we were developing this test what that structure looks like. And that is how, so the analytical studies are done much before. So we looked at that structure, and that is how the test was built for a layer lamp. Now, right now, we are looking for urine, the structure for HIV negative and HIV positive is understood, and that is how the tests are being built. The difference is that there is a new test that we are trying to develop, is trying to detect lamb from breath, which is a completely different structure. So
Yeah.
we study those using basic science mechanisms, mass spectrometry, and doing structural biochemistry to assess them, and then use the same similar antibodies before we actually get to the point of making a test.
Okay. And one last question. Actually, we saw that the SARS-CoV-19, whose primary reservoir was not actually human. To the many theories were that the primary reservoir was some other, maybe pangolin. If I'm not wrong. So, what do you think? Is it possible in case of MTBC complex, where there are multiple mycobacteria which are causing TB-like disease in different hosts? So, is it possible for any of this, for example, mycobacterium avium or marina, to cause cross infection in humans with the same symptoms?
Yeah, I think it's something that I am not very confident answering, because as of now, the studies have basically not looked at or not suggested that there is zoonotic transmission. So there is a zoonotic, there is TB that we try to deal with in animals, but we have not seen any evidence of transmission across different species. But I will again say that it is something that I'm not very confident answering. Yeah.
Sure. Thank you. Thank you so much, ma'am, for the nice and wonderful talk. And I hope our students have gathered a lot of information from about tuberculosis from your talk, and I hope it will help them in their near future. So thank you so much once again for joining us and giving
Thank
your precious time. Thank you.
Great. Thank you.